welcome back to Herbs class. 5 more minutes of math, man. I told you this day was coming. We here. Yeah, buddy, derivatives. Now, make sure before you check this video out, you check out the one on tangent lines and instantaneous rate of change. Because I'm going to be talking about some stuff that we went over in that video. All right? So remember what derivatives are and what derivatives give us. Yeah, that's exactly what derivatives tell us. They give us the slope of the tangent line to a curve at any point. That derivative can tell us what the curve is doing. Is it going up? Is it going down? Is it going down fast? Is it going up slow? All of that information we can get from the derivative. Now, the derivative is not a bang magical answer. To do a derivative, to take a derivative, is actually a process, right? And there are a couple of steps depending on what kind of function you're trying to find a derivative of. Right? So remember this. The derivative tells us the slope of the tangent line of a curve at any point. Right? Any point. Let's look at a curve real quick. Yeah, something like that. Right? Let's say I wanted to know how fast this curve is moving at some x value. Let's call it, I don't know, 10. Now, before I would have to draw a tangent line and kind of like estimate, like this. I would draw a tangent line, I would establish some points on that tangent line and kind of estimate the slope and the tangent. And it seems like a lot of estimation and approximation. Them days are gone. We don't have to estimate and approximate anymore. The derivative is going to give us an exact value for that slope at that point. Yeah, exactly right. But before we get into how to actually do the derivative, a little bit of vocab. These are some of the phrases that you'll see when it's time to do a derivative, right? Differentiate is kind of the verb that means undergo the derivative process, right? And there's a process. Now, y prime, that's an apostrophe. Y prime is the derivative of the equation y equals. When you're given y equals and you do a derivative, the new equation is called y prime. The derivative equation, y prime. Same thing for f of x. If your equation is given to you in f of x form, function form, your derivative is f prime of x. Yeah. And now you'll see something that looks like this also. This is the derivative of y with respect to x. And what that means is y is an equation and x is the variable being used. Now if that changes, like let's say we have a equals some equation where t is the variable. I would take the derivative of a with respect to the variable t because that's the variable being used. Yeah, so you're going to see stuff like this and that means that we are undergoing the derivative process. Now, one very, very important thing to understand is you do derivatives differently for different types of functions. So we're going to talk about one type of function today, the easiest one to start out with, but when you're doing derivatives for trig functions, it's very different from when you're doing derivatives for log functions or when you're doing derivatives for exponent functions. Today we're going to talk about polynomial functions. To do the derivatives for polynomial functions is a certain way. We're going to talk about that now.